Hello and welcome to my demo and overview of my latest project, ClubUp. ClubUp is an iOS golf utility app to help players take out the uncertainty of golf and replace it with accurate mathematical results. In this app, I allow players to calculate the true distance between them and their target, factoring in variables that most rangefinders cannot, such as slope, lie, wind direction, wind speed, precipitation, temperature, and even altitude. Beyond that, the app can also allow players to create a virtual representation of their golf bag with capabilities such as club recommendation and good shot tracking. To pull this app off, I crafted mathematical equations and algorithms as well as used the power of SwiftData and SwiftUI to build an optimized and comprehensive app. So let's dive in. Let's start now with the foundational aspect of the application, and that is our data representation models. Models are essential to the MVVM architecture, and lucky for us, Apple has released the new and exciting SwiftData framework to make this process of modeling and persisting our ClubUp data much more streamlined. There are a couple of reasons why I decided to use SwiftData. First and foremost, I knew that it was a relatively new technology, and that simple fact excited me, and I wanted to take my first dive into it. Secondly, the only previous other data persistence technologies I had worked with were Firebase, Firestore, and Core Data. Firebase utilizes cloud technology, which although powerful, was not necessary for this application. In Core Data, I had worked with back in college, and I knew it would require a bit of a refresh to learn how to work it into this app. So even though SwiftData was also new to me, from everything I could find online, it seemed like a great choice for this app. But before we take a look at my SwiftData models, let's take a look at two classes that were also helpful data structures. Starting with weather data, this class simply defined a number of structs to represent the JSON structure that would be received from the API request to open weather. These structs match exactly the hierarchy of what is in the API response and allow me to dig into that data that I was specifically looking for. These structs allow for future expansion if I wanted more data points. All I would have to do is add the appropriate properties here. Specifically, any struct that uses the codable protocol is a direct representation of data in the API response, as the codable protocol is used for converting the data into and out of external data representations. Next up is my special types class. This class defines a number of enums that are mostly unrelated to each other, hence their inclusion into this file. These custom data types are used throughout the application and serve as a way for me to differentiate between them with added flexibility that standard data types do not have. Before we talk about the main SwiftData model, Club, let's quickly talk about user prefs. As titled, it defines the structure and properties of global user preferences. These properties allow the user to control their ClubUp application experience in some small and significant ways. First of all, you can see that we import the SwiftData framework and use the @ for a model macro to convert this Swift call into a persistent data structure that is managed by SwiftData. We can see below the properties representing each preference, and I'm using our special types here. Below that is our constructor. There was no need to include a convenience constructor, but I did provide some default values to initially populate the model. Moving below, we have only one method for the class. Now it is preferable that only one userPref model object exists at any one time, and that it would not need to be queried from the typical SwiftData model storage since only one would exist. I was hoping it would just be persistent and quickly accessible. This was early on in my journey building this app, and I just did not put together a solution to fit the bill. So for the moment, there are controls in place to only allow one userPref model to exist, but it still must be retrieved just like any other SwiftData model. Hence, this method abstracts that access procedure so that it can still be grabbed directly. Let's move now to Club. This is one of the first classes I started working on, and it paved the way for the development of the rest of the application. The purpose of the Club SwiftData model was to create a virtual representation of a golf club. There's a lot of data that can be associated with a golf club. Some are purely informational, and some are pertinent to the golfer's decision-making on the course. I cover both types with this model. Properties such as brand, model, and name are used solely to add customization to the club's identity, whereas number, degree, distance, and rank are all values that are important to the calculations of this application. We can see that I use one of my custom enums here as well to help differentiate what kind of club the model is representing. Beyond that, there are a couple of properties. Favorite and shots, good shots, are used for recommending the club in certain scenarios, and displaying what % of shots a user hits well with this club. Because this SwiftData model is the core of the application, there are bound to be a good number of additional structures that can be used to help manipulate and create these objects. I'll give snippets of interesting information for each. Recommended clubs is a static property for quickly retrieving a list of default clubs with no custom information. The createClub method does exactly what you think it does, utilizing specialized submethods for each of the club types to create club objects. The important thing to note here is that createClub can be passed the distance in either yards or meters, and will make sure that both fields are filled when the club is created. That way, the user does not need to enter the values for both units if they want to switch. It is automatically populated with the help of some helper methods. In each of the specialized createClub methods, I am performing logic to correctly provide a name for the club based on the given information. In golf, however, there is some variation to this, and some edge cases to watch out for. For example, a pitching wedge is usually considered an iron rather than a wedge, so that must be accounted for. Below that, we can see the methods used to automatically calculate and populate both distance fields, in cases other than creating a new club. The rank calculation method is another instance of having to account for golf's variations in naming conventions. Rank is vital for ordering the clubs in the club list view, and this is done by determining the club's number or degree, depending on what information is provided, as irons will always be referred to by their number, while wedges are sometimes referred to by their degree. Last of all, I have a static method here that performs the necessary checks on whether or not a user's current set of virtual clubs are missing any of the default clubs. This was obviously a lot of information, but you can see the diverse ways in which this class is used and manipulated by the expansive logic that is included here. Last but not least of the data models is calculation. This was added later in the development as a means of better abstracting and handling data from the calculator input. As you can see, I'm importing SwiftData here, but this is not actually a persistent SwiftData model, it just utilizes others. With the properties, we start with all the constants we need to fill out the different fields of the form, and below that are more involved data properties for loading in data from other models. And finally, we have the calculation properties, which correspond to all the values needed to calculate the true distance, as well as some additional functionality. Because this is a Swift class and not a SwiftUI class, in order to use SwiftData models, we need this fetchData method to query whatever objects we need. In this case, user preferences. My getWindDirection method takes the string values that represent the arrows for wind direction and converts them into numeric offsets that can be used in the calculation formula. GetSlopeLieFactor method is not included in the calculation formula, but it is important in recommending which club to hit. Determining the effect on distance different lies have is variable, but there exist general rules for clubbing up or clubbing down depending on the condition of the lie. At the bottom here, we have our location and weather data retrieval. The location is acquired through the CL Location Manager delegate, which when we use request location will either call this location manager with did update locations or did fail with error, depending on whether or not the retrieval was successful. I have also set it so that if we are successful retrieving the location, then I perform the API call to Open Weather API. Now I have plans to more gracefully handle the failure here, but for the moment we will just log the failure. To perform the API call, we construct a URL with the pieces of data we need from the user's location, and then use URL session and JSON decoder to retrieve and format the incoming data. The last thing we do is update the calculations model property, which is binded through the ViewModel to the view, and so the UI fields will be automatically updated. Let's now talk ViewModels. ViewModels are the middleman between our views and our models, handling user interaction and performing important processes on our data. SwiftData is powerful in that it can be coupled tightly with SwiftUI, so much so that you may not even need a ViewModel for adding, deleting, or filtering your data. However, there are limits to how much can be done with SwiftUI and SwiftData. For example, we can utilize SwiftData in our model context to add or delete clubs directly from SwiftUI, but we cannot expect SwiftData to contain the logic necessary for our distance calculations in the distance calc view. So although I did not have to write a ViewModel for every view that I created, I did need two to help create some of the more complex functionality within the app. Let's take a look at the distance calc ViewModel. As the top comment shows, this ViewModel supports the data collection and calculation logic of the distance calc view. To help with organization, separation of concerns, and potential reusability, I defined this ViewModel within an extension of distance calc view. I am also using the observable macro here, so that changes to this ViewModel can be observed from the view. Because there is logic in this class that will manipulate SwiftData models, we require the model context and a way to fetch that SwiftData, seen here with this fetchData method, specifically for clubs and user preferences. You can also see above that in my init, I am initializing a calculation object, and because calc data is a property of this view model, changes to any of its properties can be observed from the view. Initially I had no calculation model, so all of those properties and methods we looked at earlier would have had to exist in this view model, which was too cluttered, and there was already a lot going on here already. Let's move now to the distance calculation methods, starting with wind. To simplify the calculation, I forced the use of wind speed into miles per hour. But essentially what the formula is and what this code represents is that for wind directly into the player, add 1% distance to the shot for every 1 mile per hour. For wind directly from the player's back and helping, add 0.5% distance for every 1 mile per hour. This will decrease the adjusted distance. However, wind is rarely ever directly with or against a player, and can come at any angle. To account for this, we use the direction offset percentage as defined in our calculation model to determine what percentage of this adjustment to apply. If the wind is directly to the left or right of the player, then the wind is not helping or hurting, so 0% would be applied. Therefore, the calculations for wind are cancelled out. 50% of the calculation is added or subtracted if the wind is coming on an angle to the player. Moving on to altitude, the rule is that a player's carry distance will increase 1% for every 300 meters above sea level. So that value is subtracted from the current distance to account for it. So someone in the Rocky Mountains of Colorado is going to hit a ball farther due to altitude than someone like me on the Jersey Shore at around sea level. Rain is a simple factor, as the general rule is an average reduction of 4% to carry distance if it is raining. So this will increase the current distance a user will have to play for. Similar to wind, I am forcing the use of Fahrenheit when factoring temperature to simplify the equation. The rule here goes that you add or subtract 2 yards to carry distance for every 10 degrees Fahrenheit below or above 75 degrees. So a ball will travel farther in warmer weather and shorter in colder weather, aka a target will play a shorter distance in warm weather and a longer distance in cold. Now all of those methods are called here, but before I do that, I standardize the units. So the user preferences for units only reflect what is displayed, but all of the calculations are performed in imperial units, so those conversions must be performed if necessary. The only part of the calculator that is not directly tied to the distance formula is the lie and slope factors, as variations between them can be too difficult to nail down in terms of their effect on distance. However, there are trusted rules to follow that can help a user select the right club for the job based on the condition of their slope and lie. So for an uphill slope, a player should club down by 1 to account for the higher launch angle and more airtime a ball will have. The opposite is true for a downhill slope. A player should club up to get more distance on the ball, as it will likely not travel as far in the air. As for lie, if the player is in rough or bunker, they should club up 1. However, this is a general rule, as flatter lies exist in rough. For deep rough, a player should club down to a minimum of a 9 iron, because in such treacherous lie, the priority will be to just get the ball out of it. These factors, again, do not go into the distance calculation, but instead at the end when recommending the club. Let's talk about the algorithm used here to decide which club a player should hit based on the distance data from their virtual golf bag. This is a modified binary search to allow both exact matches of the club to the distance, but also the closest club to the target distance, with some additional factors such as slope, lie, and whether or not the club is marked as a favorite. I do all of the edge case checks up here. If there are no clubs, then there are no clubs to recommend. And I also check if the distance is less than the lowest number or the highest lofted club distance and vice versa. Into the algorithm, we always make sure that when a target club is found, that we also account for the lie and slope. Other than that, we can see that we are accounting for not just exact matches, but the closest number we want by using the absolute function. This algorithm may be overkill, as there may only be upwards of 15 clubs in the user's virtual bag, but it was very enticing to create such an algorithm that has the possibility to scale up and run efficiently for larger data sets. Finally, we move to the Club Create View model. As the name suggests, this view model is coupled to the Club Create View, which is the sheet that slides up for custom club creation. So this view model takes on a little bit of a hybrid role. It defines many of the properties of a club model, but ultimately uses those properties with the createClub method for creating the SwiftData object that is inserted into the model context from a button action in the view. That is its main job, but it also defines some properties that are used to fill out input selection fields, specifically club numbers depending on what type of club is chosen. It's a minimal and simple view model, but was necessary to just encapsulate some logic of the view that SwiftData on its own cannot implement. In terms of number of files, views make up the largest category. So if I were to go step by step through each one, it would be way too much. Instead, I figured I should highlight just a couple of the areas where I feel I used some interesting techniques to flesh out some functionality I had designed. Now, I am certainly no expert on UI, as this app could definitely look much better, but SwiftUI makes it pretty easy and efficient to experiment with designing the look and feel of your app. The only thing I would suggest is that you make sure your laptop is beefy enough for the SwiftUI preview feature, as my laptop is a bit old at this point and struggled with the preview feature unless I set the simulator to the standard iPhone. The first highlight I wanted to show was my Club Quick Add feature. This feature presents to the user a grid of buttons, each representing a standard club that is present in most golfers' bags. They do this with an image representing a club type and a name denoting its exact number. Giving the user this option can allow them to quickly fill out their virtual golf bag if they are not interested in setting up specific brand and model details. To make this even easier, I also added a button that would go ahead and add all of these clubs automatically. All a user has to do is fill in the distances. This is a preference feature, so it can be turned off and on whenever a user would like to clear some space from this page. It'll also only appear as long as there are recommended clubs that can still be added. Otherwise, we will just display some text and a count for the number of clubs. The isMissingRecommendedClubs method is a club function. It creates a map of club names and checks them against the recommended clubs dictionary's keys to check for missing clubs. Below that is our text and button for the Add All feature. Upon the button click, I filter out the clubs that are already in the bag, and then only add clubs in the recommended clubs dictionary that have not already been created. So a user can quick add the rest of the recommended clubs, no matter how many have been added so far. Next up, we have the grid of buttons. Like before, we are using the user's current clubs to create a map of club names that we can use to filter the recommended clubs values. Here I also use the rank properties of my club model to make sure these buttons always appear in the order that makes sense, driver to wedges. Each button has the add item method attached to its action, and each rec club object has a preset image to use to display its type. This does take a good amount of real estate on the page, but it's a feature that I think adds to the overall user experience with the application. If a user would rather have a more personalized experience with their virtual golf bag, then I also provide this option to add a custom club. Here, users can provide more details on the club they own and how they want it represented. This includes being able to add its brand, model, specific type, including the hybrid type, which is not included in the quick add, as well as specific degrees and names for clubs, and specifically wedges, since there is such a large variety of them. The variety of fields here are created with pretty standard SwiftUI components. However, the club type selector allows you to switch between each type of club and specifically adjust the below fields to match with that type. To create this effect, I am tying the club type to each button, and because those types are binded, any changes to their values will automatically reflect in the UI, so I can use that to create logic that changes the UI based on the selected type. To create the buttons themselves, I have a designated button style struct that, depending on whether or not its type is selected, will determine whether its UI will present as highlighted for selected or not highlighted for unselected. Because only one type can be set at a time, these buttons will switch between selected and unselected. I like this UI component because I think it adds a little complexity to this otherwise standard form and gives it a modern and flashy feel. It also helps direct the user step by step so that they aren't filling out specific data points without having first selected the type, which is essential for formatting other properties of the club object. The last piece of UI I'll go over are just the different settings I've included to help tailor the application to the user's liking. So this portion will be less about the SwiftUI used to create this settings page, but more about the logic in place to manipulate the SwiftUI through the application based on these settings. Here again, we are coupling SwiftData to the SwiftUI, in this case a user prefs object. This model lets us control the distance, speed, and temperature units, as well as enabling, disabling the favorites, shot tracker, and quick add features. Moving to the last tidbit here, one of the last features I put together was a string catalog. I really like the idea of having one place to store all of my string constants. That way I can just access this catalog for any string I need, and if I need to make edits, I only have to do it in one spot. So I did that, and you can see I have keys for each of the strings, although I later realized that Swift can make this very easy, just using the string itself if it's simple enough as the key. And you can see, for example, in my distance calc view, I am getting a specific string key based on what distance unit is set, and then with that key, grabbing the correct string constant to display using ns localized string. Once I completed this, I thought to myself, well, I'm halfway done with a full translatable version of the app, so why not? So I added a Spanish translation, which was very easy thanks to Apple's Quick Translate option. And this time around, I could even use the automatic localization. For example, here, also in my distance calc view where my label is clearly raining, this will automatically be translated if the language of the device is Spanish. So just a cool feature to add on top of everything else. It's not only very important, but beneficial to the success of an app to make it accessible to as many users as possible, and this is just one way of doing that. So if you got to the end, I really appreciate it. I'm still figuring out how to put together these videos in a way that is casual, but also making sure that I'm being as detailed and thorough as possible. So the question is, what's next? What will be my next project? Well, I'll be starting my master's degree soon through Georgia Tech's OMSCS program, and the first class I plan on registering for is the video game design course. So whatever I create in that class will most likely be the next project that I will create a video for, create a whole LinkedIn project for. So if you'd like to keep up to date with the projects that I work on and some of the other things I'll get up to, please subscribe. Of course, you can leave questions on this video. I'm very open to feedback. I know that I'm not the most talented software developer. Creating these videos is just a way of forcing myself to learn and get better. So thank you.